Find the sum of the first 11 numbers in this geometric series. Remember, series means when we have a list of numbers separated with addition or subtraction. Sum is our cue. We're going to be using this formula. This is a formula you will have to have memorized for the exam. I want to add up the first 11. Well, there's a couple things that you know. I need to know how many do I add up. That's 11. I need to know the common ratio from one term to the next in the series and the initial value. So our initial value is 4/3. To get the common ratio, I'm going to take the second divided by the first. Second divided by first, and end up with -0.5. Now I will say that a lot of students have had no problem coming up with this. What they're struggling with is how do I correctly plug it into the calculator to get the right answer. So I'm going to go in 3 steps. I'm going to do the numerator, the denominator, and then the outside number. 1 subtract, now it must go in parentheses. 1 subtract -0.5 raised to the 11th. This is my numerator answer. Now I'm going to divide that by 1 subtract -0.5. Again, it's in parentheses. Now I'm going to do this once again. 1 subtract -0.5 to the 11th. I'm going to divide that answer by 1 subtract -0.5. And then I'm going to take it times the outside value of 4/3. Now, nothing wrong with this, but if I can put this back into a fraction, I will. So here's my exact answer. It is 683/768. Find the sum of the geometric series. Again, sum, I'm always going to be pulled back to this formula. So in this particular problem, I know the initial is a sub 1. And I could easily find out the common ratio by taking the second value, or the second term in the series, divided by the first. Second divided by the first is 3. So I can take this times 3, times 3, times 3. We just don't know how many values are in here. So this is 3, and this is 3. We don't know how many are there. There's a couple different ways to do this, but here's what I do. I take 2.6, the first value. I know the common ratio is 3. Okay, good. Take it times 3 again. This is my third term. Once I've done something, perform an operation, the same operation, twice on the calculator, it recognizes this pattern. This is the third number. Now I'm going to count until I get to this value. 3. I press enter. There's 4. Enter. 5, 6, 7, 8, 9, 10. This is the 10th number in the series. So how does that help us? So I want to add up the first 10 numbers. I know the first number is 2.6. I know the common ratio is 3, and I'm adding up the first 10. 1 subtract 3 to the 10th. I'm going to do the numerator, then divide it by the denominator in parentheses, and then multiply it by the outside number. And again, you can leave that as a terminating decimal or put it into a fraction of your choice. It is a terminating decimal, so you could leave it as you see it. Either one of these answers would be acceptable. Number 4. Alex asks her friends to help advertise about an upcoming charity car wash to help raise money for the Spread the Word to End the Word campaign. The group plans to ask for monetary donations instead of pre-selling car wash tickets. Alex instructs her closest 3 friends, so that's initially. I want to circle that. This is your initial amount. Her closest 3 friends to take a stack of flyers and pass them out to each of their 4 closest friends. Okay, so that's the next thing we're going to do. Start with 3 and then go 4. So visually, it looks like this. Here's Alex. She says, hey, my 3 close friends, I'm going to give you a stack of flyers, then you pass them to your 4 closest friends. And we're going to continue to do this, assuming that no one receives a duplicate copy of a flyer. At the end, excluding Alex, how many will have received a flyer after the 5th level of friends? So we keep going level after level. So I prefer just to use the formulas. For example, there's 5 levels. My initial amount is 3 people get it. After that point, they're told to continue to pass it each time to 4 people. Common ratio is 4, and we want to go to the 5th level. 1 subtract 4 to the 5th, divided by 1 subtract 4 in parentheses, and times the 3 out front. Now, how else could we have done that? Okay, we could have recognized the pattern. You start with 3, and then each one of these 3 get 4, so 4 plus 4 plus 4 is 12. I could have recognized this pattern and gone 3 times 4, okay, 12, times 4, 48, times 4, 192, times 4, 768. The mistake I've seen the students make in the past is they assume this is the final answer. This is the stopping point, but it's the sum of all of these. So if I take 768 plus 192 plus 48 plus 12 plus 3, I will get the exact same answer.